If you are looking to increase the throughput and precision of your automated microscope system, direct drive stages offer higher speeds and better repeatability than stepper and screw-based motion systems for XY sample positioning and Z objective focusing. When using a screw-based actuator, in order to have high resolution, you end up needing a fine-pitch screw, and what that does is it limits the stage's velocity. With a direct drive stage, with linear encoder feedback, you're not limited in that way, so the only contacting portion of the stage is in the bearings. For imaging applications, we use a cross-roller bearing for our XYZ stages. This has high stiffness and supports high velocity motion. The non-contact direct drive linear motor and precision encoder will, with typically a 5 nanometer resolution, provides fast and repeatable positioning. Our first webinar shown here on this page is called Maximizing Throughput in Fluorescence Microscopy. And that's a discussion between our CTO, Kevin McCarthy, who's a 40-plus year veteran of motion control, and Steve Auger, who's an optical design expert from BioDevice Partners. Discussion topics include optimizing for scanning motion or field-to-field motion, benefits of custom automated microscopes, some tips and tricks for optical design, and compact multi-channel fluorescence microscopy. All topics are geared towards maximizing size, throughput, and performance of an imaging system. We've also got a webinar that we did jointly with WDI Wise Devices that talks about how to use a hardware laser autofocus system in order to maximize focusing throughput. With a laser autofocus, every time you move to a different area, you do not need time-consuming software contrast-based algorithms processing multiple images at different Z heights to determine the focus plane. Instead, with a laser autofocus system, the laser autofocus hardware will directly command the Z objective motion axis to be within the depth of field to ensure clear images. As far as white papers go, we've got a couple on the topic. There's an optimizing motion for sequential field imaging, which explains how to use feed-forward tuning settings to overcome static friction in the system, which reduces the falling error during the move. This greatly improves the overall step and settle time of the sample or objective for imaging applications. In this, we also covered different move profiles, a traditional trapezoidal move compared to adding S-curve or jerk, which is the derivative of acceleration. Adding that term into your trajectory helps to smooth out your acceleration so there isn't a big impulse on the system and you're not exciting a lot of resonances that may be inherent to your system structure. We also cover a proprietary method that we have to optimize and learn from the actual structural resonant frequencies in your system and optimize the move trajectory in order to ensure that the move can be completed in as quick a time as possible. And we've seen dramatic improvements to the move and settle times with this method, in some cases even up to 10 times faster. This approach works for field-to-field sample positioning moves as well as Z objective moves for Z image stacking applications. In addition here, we've also got a new technical white paper that is specific to high-speed Z image stacking, how to optimize motion for looking at different planes within a tissue on a slide or cells within a well plate. This also includes timing considerations for motion and camera image download speed. The next section is product-specific white papers. The DOF5 discusses benefits versus piezo and screw-based approaches to objective focusing motion and provides example move and settle plots, what you can expect for performance, and a compare and contrast between the DOF5 and some piezo technologies that you may be using today. And then we also have a white paper on the SmartStage XY that goes through the technical benefits of that product line with single cable and embedded controls and compares that to bulkier, slower, less precise stepper and screw-driven stages. We also recently released a 100-page printed white paper booklet. Covers a lot of topics here and additional ones around optics, motion, and how to combine the two and really optimize your optical imaging application. Feel free to reach out to us, and we're happy to mail you a copy of that printed white paper booklet with selections from our CTO, Kevin McCarthy. Thank you.